The Sun, our closest star, is the powerhouse of our solar system. It fuels life on Earth, drives our climate, and dictates the rhythms of nature. But what if one day, the Sun suddenly disappeared? Sit tight, because things are about to get a little dark. The first thing we'd notice if the Sun disappeared would be, quite obviously, darkness, but not instantaneously. Due to the finite speed of light, it would take about 8 minutes and 20 seconds, the time it takes for sunlight to reach us, for Earth to plunge into darkness. The sudden darkness would also impact our satellite communication systems, causing widespread disruption to telecommunications, weather forecasting, and GPS navigation. But the effects wouldn't stop at darkness. The Sun's gravity holds our solar system together. Without the Sun's gravitational pull, the planets, asteroids, comets, and other celestial bodies would be sent hurtling off in straight lines into space. Over time, our solar system would become unrecognizable, as planets and other objects would no longer be held in their orbits and would travel aimlessly through the cosmos. Although the Sun's heat would no longer warm the Earth's surface, the Earth's core would continue to produce heat through the radioactive decay of isotopes. This residual heat would fuel volcanic activity and plate tectonics for some time, potentially resulting in an increase in earthquakes and eruptions as the planet cools. Back on Earth, things would quickly start to chill. Without the Sun's heat, our planet's surface temperature would drop to around -18 degrees Celsius or 0 degrees Fahrenheit within a week. The oceans would start to freeze over, and within a year, the top layers of our seas would turn into ice. The Earth would eventually stabilize at an average temperature of around -240 degrees Celsius, or -400 degrees Fahrenheit, which is the temperature of the cosmic background radiation. As temperatures plummet, Earth's atmosphere would undergo drastic changes. The gases in the atmosphere would freeze and fall to the surface, starting with water vapor, followed by carbon dioxide and eventually nitrogen, creating a layer of frozen air on the ground. Without sunlight, photosynthesis would cease, disrupting the food chain at its most fundamental level. Most life on the surface would perish, but some organisms could survive. Deep-sea hydrothermal vent communities that don't rely on the sun for energy would continue to thrive. Some bacteria and fungi, which can live on chemicals, might also survive. In the pitch-black depths of the ocean, bioluminescent creatures would continue to illuminate the darkness, providing a glimmer of hope in an otherwise bleak situation. The world would be pitch black, but not entirely without light. The stars, moon, and planets would still be visible, reflecting the light of distant stars. The night sky would be far more spectacular, with distant galaxies and the Milky Way visible from everywhere on Earth. But without the sun, these celestial bodies would appear as stationary points of light, as Earth would no longer be orbiting the sun, causing the loss of day-night cycles and seasons. With the disappearance of the sun, the dynamics of our solar system would be irrevocably altered. The planets, no longer bound by the sun's gravity, would be flung out into the cosmos, potentially colliding with other celestial objects or being captured by the gravity of other stars. The asteroid belt and the Oort cloud, the source of our solar system's comets, would disperse, scattering asteroids and comets throughout the galaxy. The disappearance of the sun would also have significant implications for space travel. Without the sun's gravitational well, launching spacecraft to other planets or beyond our solar system would become a significantly greater challenge. Furthermore, any astronauts or probes currently in space would be stranded, their communications with Earth cut off, and their solar-powered systems rendered useless. So, as we can see, the sudden disappearance of the sun would have catastrophic consequences, resulting in a dark, cold, and lifeless Earth drifting through the cosmos. This sobering hypothetical scenario underscores the sun's vital importance to life as we know it and our planet's delicate position in the cosmos. But don't fret. This scenario is purely hypothetical. In reality, our sun isn't going anywhere anytime soon. It has enough nuclear fuel to continue burning for about another 5 billion years. And when it does start to run out of fuel, it won't just disappear. It will undergo a series of fascinating stages, swelling into a red giant, and eventually shedding its outer layers to leave a white dwarf. But that's a story for another time. We hope you've enjoyed this exploration into the realm of the hypothetical. If you're as fascinated by these possibilities as we are, please give us a thumbs up, share this video with your fellow space enthusiasts, and subscribe to our channel for more deep dives into the cosmos. Until next time, keep looking up and never stop questioning.